Hello! This video is a tutorial on solving dilution problems. I have also included some practice questions to serve as examples and for you to master the topic, particularly the calculations. So let's proceed right away to the formula we use in solving dilution problems in chemistry. Always remember that when you do dilution, you have a more concentrated solution and you make it less concentrated. So the formula is C1V1 equal to C2V2. The left side of the formula is for the more concentrated solution. Or if you read other references, they call this the stock solution. The right side of the formula is intended for the less concentrated solution, or the other term is dilute solution. C1 stands for the initial concentration or the concentration of stock solution. V1 is the initial volume or the volume of stock solution. C2 is the final concentration or the concentration of diluted solution. And lastly, V2, this is your final volume or the volume of diluted solution. So C1V1 equal to C2V2. So let's apply the formula by answering question 1. What will be the concentration of HCl if 2 ml of 12 molar HCl is diluted to a volume of 50 ml? So the problem says we have 2 ml of 12 molar HCl. So 2 ml, 12 molar. And you dilute it to a volume of 50 ml. And the question is asking for the concentration of the diluted solution. So the concentration is unknown molarity. So to solve this, we use the formula C1V1 equal to C2V2. C1 is the initial concentration, which is 12 molar. V1 is the initial volume, which is 2 ml. C2 is unknown, so just write C2. And V2 is the final volume, which is 50 ml. To solve for C2, divide both sides of the equation by 50 ml. So 50 ml cancels on the right side, and what remains on the right side is C2. And on the left side, we have 12 molar times 2 ml divided by 50 ml. So ml will cancel, and our unit on the right side would be molar. So grab your calculator and type 12 times 2 divided by 50, the answer is equal to 0.480 molar. So this will be the final concentration. Now that you have an idea on how to use the formula, you can pause the video, read question number 2, solve it on your own, and when you have the answer, you can go back and play the video. So question 2, to what volume should 4.50 ml of 18 molar H2SO4 be diluted to obtain a concentration of 2 molar? So it says here you have 4.50 ml of 18 molar sulfuric acid. So 4.50 ml, 18 molar. And you diluted it to 2 molar. So the final concentration is 2 molar. And the problem is asking for the volume, the final volume. So unknown volume. So question mark ml. Again, we use the formula C1V1 equal to C2V2. The initial concentration is 18 molar. So C1 is 18 molar. Initial volume is 4.50 ml. That's your V1. C2 is the final concentration, which is 2 molar. That's your C2. And V2 is unknown. So you just put V2. So to solve for V2, divide both sides of the equation by 2 molar. So that 2 molar cancels on the right side, and what remains on the right side is V2. On the left side, molar will cancel. So you have 18 times 4.50 ml divided by 2. That is equal to 40.5 ml. So this is your V2 or the final volume. Question 3, again, you can pause the video, solve this on your own, and then get back if you have an answer. What volume of 15 molar HNO3 should be diluted to make 0.250 liters of 1 molar solution? So the problem says that you are making 0.250 liters of 1 molar solution. So that means this is your final solution or your diluted solution. 0.250 liters and the concentration is 1 molar. And you will make this from 15 molar HNO3. So your initial concentration is 15 molar, and the problem is asking for the volume of the initial concentration. So the volume is unknown, so question mark liters. So let's use the formula C1V1 equal to C2V2. C1 is 15 molar. That's your initial concentration. V1 is unknown, so just write V1. C2 is your final concentration, which is 1 molar. And V2 is your final volume, which is 0.250 liters. So to solve for V1, divide both sides by 15 molar. So 15 molar cancels on the left side, and what remains on the left side is V1. And on the right side, molar will cancel. So you have 1 times 0.250 liters divided by 15, and that is equal to 0.0167 liters. So this is your V1. Now, students usually ask, Is it okay that the answer is in liters, or should I convert this to ml? Well, the answer is it's not necessary to convert your answer to ml if the problem does not require a specific unit. So if you read the problem, it doesn't say that the answer must be in ml. So what I do is I just stick to the units in the problem. If you read the problem, the unit of volume is in liters. So my answer must be in liters as well. Okay? Question 4, you can pause the video and get back if you have an answer. 100 ml of 0.375 molar ammonia was prepared by diluting 2.50 ml of concentrated ammonia. What is the concentration of the concentrated ammonia? The problem says that you are preparing 100 ml of 0.375 molar solution. You are preparing it, so that means it is your final solution. So 100 ml, 0.375 molar. And you are preparing it using 2.50 ml of concentrated ammonia. So the initial volume is 2.50 ml, but the concentration is unknown. So question mark molarity, molar. We use the formula C1V1 equal to C2V2. C1 is the initial concentration, which is unknown. So just write C1. V1 is 2.50 ml. That's your initial volume. C2 is 0.375 molar, your final concentration. And V2 is 100 ml, your final volume. To solve for C1, divide both sides of the equation by 2.50 ml. So on the left side, 2.50 ml will cancel, and what is left is C1. And on the right side, ml will cancel, so you have 0.375 molar times 100 divided by 2.50, and this is equal to 15.0 molar. So this is the concentration of the concentrated ammonia, or the initial concentration.